What does it take to dig a tunnel wider than a 5-story building under one of Earth's most unpredictable rivers in just 110 days? It seems impossible. Building tunnels underwater is normally complicated, risky, and takes years to finish. Yet China's engineers have done exactly that with the Jinan-Huang'an Road Tunnel. Let's break down how China achieved what many called unthinkable. This massive underwater tunnel sits beneath China's Yellow River near the city of Jinan in Shandong province. It's currently the largest underwater shield tunnel ever built, with a diameter of about 17 meters, that's around 56 feet wide. Now the question is, why was this tunnel even needed in the first place? Jinan earned the title of China's most congested city 2 years in a row. Traffic jams here cost the economy over $2.3 billion annually in lost productivity and fuel waste. For the 9.4 million people of this city, crossing the Yellow River has long meant battling traffic jams, varied delays, or risking outdated bridges. For decades, this ancient river carved a line between the city's bustling downtown and its fast-growing northern districts. But until recently, they only had 2 main options: bridges or ferries, both slow and often overcrowded. Bridges frequently experience heavy traffic jams, especially during rush hours. During holidays, queues stretch over 4 miles, turning a 10-minute crossing into a 90-minute ordeal. Ferries are even slower and can't handle large numbers of commuters efficiently. Clearly, Jinan needed a better solution to connect its northern and southern regions. So why not just add more bridges? Well, building a bridge here is tricky. The river geography limits options. Its shifting banks and protected ecological zones restrict construction. Existing bridges already occupy all stable crossing points, and adding more would require demolishing neighborhoods housing 240,000 residents. Engineers faced a critical choice: risk a structure that could sink into soft silt or fight the river on its own terms by going under it. In September 2024, China's infrastructure teams chose the latter, launching a bid to construct the world's largest underwater tunnel. The goal was to build a 5.4 kilometers highway tunnel, 3.6 kilometers of which runs under the Yellow River, buried 150 feet below the riverbed, capable of moving 30,000 vehicles daily. The underwater section alone surpasses the length of the Golden Gate Bridge's main span by 450 meters. Engineers opted for a double-decker design to maximize capacity without widening the structure. The upper level carries 3 lanes southbound, while the lower level handles 3 northbound lanes. This configuration moves 30,000 vehicles daily, equivalent to adding 6 new bridges across the river. Drivers will maintain a 60 km/h speed limit, with AI-controlled traffic lights at entry points to prevent bottlenecks during peak hours. Safety drove critical design choices. The tunnel features 27 emergency exits, spaced every 200 meters each, leading to elevated walkways above potential flood levels. 16 jet fans per kilometer ensure air quality, capable of full air replacement every 3 minutes. The 1.2-meter thick concrete walls withstand water pressure equivalent to 40 adult elephants pressing on every square meter. Construction required 2,164 prefabricated concrete rings, each weighing 72 tons, comparable to a fully fueled Airbus A3. 20 workers installed these rings at a pace of 1 every 90 minutes, 24 hours a day. The precision needed was staggering. Laser guidance systems kept alignment errors below 5 mm across the entire route. Some experts initially doubted the timeline. Typical projects of this scale take 3 years or more. Compressing it to 110 days required rethinking every construction phase. The team achieved this by prefabricating 92% of components off-site and using a just-in-time delivery system that reduced material storage needs by 80%. Environmental concerns shaped the approach. Unlike traditional dredging methods, the tunnel's construction disturbed only 15% of the riverbed habitat. Sediment filters treated 6,000 cubic meters of excavated material daily, recycling 98% for use in nearby road projects. But here's the catch: the Yellow River's bed is not solid rock. It's a constantly shifting mix of sand, silt, and water pressure strong enough to crush a submarine. So how do you build a tunnel here without it collapsing? Let's start with the machine that made this possible. Enter the Shanhai, a tunnel boring machine heavier than 400 elephants. This machine is huge, measuring 17.5 meters in diameter and weighing around 4,200 tons. That's roughly the weight of 10 fully loaded Boeing 747 airplanes. But size alone is not what makes Shanhai special. This machine was built specifically to handle extreme underwater pressures and challenging geological conditions beneath the Yellow River. Powered by a cutterhead generating over 7,500 horsepower and an astonishing 26 million pound-feet of torque, Shanhai can cut through clay, sand, rocks, and silt with ease. On average, it advanced between 16 to 18 meters, or about 52 to 59 feet, every single day. That's significantly faster than most tunnel boring machines operating today. What set the Shanhai apart was its real-time adaptation capability. Over 3,800 sensors monitored 47 parameters, from groundwater pH levels to metal fatigue in cutter teeth. When the machine encountered an unexpected granite layer 12 meters below the riverbed, its AI recalculated pressure settings in 8 seconds, a task that would take human engineers 45 minutes. The system automatically adjusted hydraulic pressure by 18% to maintain progress without stopping. Maintenance challenges were unprecedented. Each of the 432 cutter teeth required replacement every 35 meters of excavation. Crews developed a rotating repair system. While one team replaced 12 teeth on the cutterhead's left quadrant, another serviced the right, keeping downtime below 22 minutes per shift. River conditions tested the TBM's limits. At its deepest point, 48 meters below the water surface, external pressure reached 580 kilopascals, enough to crumple a submarine. The machine's pressurized cabin system maintained a stable 101 kilopascals internally, allowing workers to operate without specialized diving gear. Productivity metrics outpaced conventional TBMs by 260%. While standard 15-meter machines average 6 meters daily in similar conditions, the Shanhai achieved 16 to 18 meters. The Yellow River's bed is like quicksand. To keep the tunnel from collapsing, the Shanhai laid a protective shell as it moved. Think of it as a 3D printer for concrete. Every 2 meters, it installed a ring made of 10 curved segments. Each ring weighed around 72 tons and locked into place with millimeter precision. Environmental safeguards were integral. The TBM slurry system filtered 98.7% of particles above 0.1 millimeters, preventing river contamination. Thermal sensors shut down operations if lubricant temperatures exceeded 63 degrees Celsius, protecting nearby aquatic ecosystems. Now you might ask, how do you steer something this massive? The answer lies in hundreds of sensors dotting the TBM's body. They measure soil pressure, alignment, and even tiny shifts in the riverbed. Adjustments happen instantly. Lasers guide the machine's path while hydraulic jacks push it forward. It's like performing heart surgery with a 4,200-ton robot. Let's look at the actual construction process of how they did it. Crews first stabilized 1.2 kilometers of the Yellow River's southern bank. 16 sheet pile walls, each 32 meters deep, created a dry work area. Dredgers removed 860,000 cubic meters of sediment, enough to fill 344 Olympic swimming pools, to create a level tunneling path. Simultaneously, workers laid 18 kilometers of rail tracks to transport the TBM components. Assembling the Shanhai required 14 days, 3 times faster than typical 15-meter TBMs. Every 2 meters, the machine paused for 38 minutes as workers installed a 72-ton concrete ring. Night shifts focused on maintenance, 12-hour windows to replace cutter teeth, recalibrate hydraulic cylinders, and inspect 3.8 kilometers of electrical cabling. Day shifts maximized progress, with 14 concrete deliveries arriving hourly to keep pace. Weather posed unexpected hurdles. October rains flooded access roads twice, but preposition pumps diverted 12,000 cubic meters of water in 9 hours. November temperatures dropped to -7 degrees Celsius, prompting engineers to heat grout mixtures to 35 degrees Celsius to prevent curing delays. By October, it hit a record 1,396 feet dug in 30 days. But speed came with risks. The riverbed soil changed every few meters, one moment hard clay, the next watery sand. Over 1,500 workers from China Railway 14th Bureau Group clocked 12-hour shifts with one rule: never let the TBM stop. The project also birthed innovations. Workers designed a foam injection system to cool the TBM's cut-ahead, saving 90 minutes daily. By the end, 43 patents were filed, from soil recycling methods to a new type of concrete that hardens 30% faster. Love it or hate it, this project pushed both humans and machines to their limits. The Yellow River shelters over 160 fish species. To protect them, crews installed 8 miles of silt curtains, floating barriers that trapped sediment. Noise levels stayed below 75 decibels, quieter than a blender, to avoid disturbing aquatic life. It's a balancing act: build fast but leave the ecosystem intact. Let's put this project in perspective. The Yellow River Tunnel is the world's widest underwater tunnel but not the longest. Its 17.5-meter diameter eclipses the Channel Tunnel's 7.6 meters and Norway's Rogfast 14.4 meters. To visualize, you could fit 2 subway trains side by side inside this structure. But here's the twist: building wider is often harder than building longer. More space means more stress on the walls, especially under a river that shifts daily. Speed-wise, this project set a new benchmark. The 110-day timeline for the underwater section beats the Channel Tunnel's 6-year dig and even China's own Chengdu Strait Tunnel at 3 years. Costs matter too. While exact figures are unknown, analysts estimate the tunnel cost $95 million. Compare that to Norway's Rogfast, which will cost $2.1 billion for 16 miles. But cheaper doesn't mean easier. The Yellow River's soft soil required custom engineering that added millions to the budget. China has a long history of tackling huge infrastructure projects quickly, building high-speed rail lines, massive airports, and extensive subway networks faster than almost any other country. But even by those standards, completing this underwater tunnel in just 110 days is extraordinary. So what's next? Well, China's planning a 76-mile tunnel across the Bohai Strait, a $45 billion project that would connect Yantai to Dalian via an undersea shortcut. Engineers say it'll take 12 years, but after Jinan's 110-day sprint, could they do it faster? Let us know in the comments.